Hello guys, so you're welcome to Nisike Academy. If you're not subscribed to this channel, do well to hit the subscribe button and of course like the video. At the end, you can also share to your friends, share to everyone who loves chemistry, every lover of chemistry. In this video, we're going to be looking at Lewis structures. We're going to be looking at formal charges and also resonance structures. Alright, so basically, what are Lewis structures? Lewis structures are structures or diagrams which shows the bonding of atoms in a molecule or compound and the lone pair of electrons in the compound or molecule. Alright, so Lewis structures are very significant in you knowing the skeletal or the actual diagrammatical illustration of a molecule or compound. Now, it's very important for us to know this in chemistry. Okay, so basically, how do we draw Lewis structures? Alright, so we are going to start with the first one. You can see a question on the board. Draw the Lewis structure of each of the following. And the first one is CH4, which is methane. How do you draw that of methane? So basically, there is a formula. So we start by calculating bonding electrons. So bonding electrons are basically the electrons that are in the bonds of a particular Lewis structure of a compound. So what is the formula? Bonding electrons is equals to total octet electrons minus the total valence electrons. Alright, so I'm going to be explaining this concept. What do they mean? I'm going to be explaining that for you. So it's denoted as x equals to O minus V. Now, what are octet electrons? Now, I want to let you know that octet state is actually a maximum of 8 electrons. Alright, so when an atom of an element can attain a maximum of 8 electrons in the outermost shell, it means that that atom can attain the octet state. Okay, but not all elements can attain octet state. Okay, elements that you know, oxygen, nitrogen, carbon, they can attain, except for hydrogen. Hydrogen cannot attain octet state. Okay, it has a maximum of 2 electrons in its outermost shell. Maximum. That is the maximum number of electrons that it can attain. That's not the actual. When we talk about the actual, when we talk about the actual electrons in the outermost shell, we talk about valence electrons. We'll come to that. Alright, noble gases also, they've already gotten 8 electrons in the outermost shell. So that's why they don't participate in chemical bonding, because they don't need more electrons. Okay, so you will not see something like NeO2, neon oxide, or KrO2, krypton oxide. Noble gases we know: krypton, argon, neon, xenon, radon. These are examples of noble gases. They are in group 8 of the periodic table. So basically, how do we navigate through this? Now, it's important for us to know octet electrons. Now, what are valence electrons? Like I said, don't forget, octet electrons actually means attaining octet state, and every element has 8. But hydrogen has 2. Don't forget that. Now, for valence electrons are the actual number of electrons in the outermost shell of an atom. Okay, so valence electrons are usually the same as the group of an element. Don't forget that. Now, let me explain this. Hydrogen is in group 1. So hydrogen has 1 valence electron. I'm going to be giving you common elements that are usually partaking in chemical bonding and their number of valence electrons. So if you forget the valence electron of an element, don't forget that it is the same as the group. Hydrogen is in group 1, so it has 1 valence electron. Sodium is in group 1 as well. Potassium is in group 1, so they have 1 valence electron. Let's go to 2. Magnesium is in group 2. Calcium is also in group 2. 2 valence electrons. Group 3. Boron and aluminium, they are in group 3, so they have 3 valence electrons. Okay, we also have in group 4, we have carbon and silicon. Carbon and silicon, they have 4 valence electrons. Group 5, nitrogen and phosphorus has 5 valence electrons. Group 6, which are called the chalcogens, we have oxygen and we have sulfur, 6 valence electrons. In group 7, we call them halogens. We have chlorine, fluorine, iodine, bromine. They have 7 valence electrons, so it means that they are in group 7. Alright, so please take that into consideration. Create a table, you write elements, then you write valence electrons. That's what you should do. Now let's come back to these. Now let's calculate the bonding electrons. Now X will be equals to octet electrons. I told you that for carbon, an element like carbon attains the octet state. And the only thing that you can think of when it comes to octet is that every element has 8, except noble gases and hydrogen. Hydrogen has 2. Alright, so we'll calculate for O first. Alright, let's calculate for O. Now, carbon, total octet electron, which means I will add the octet electrons of the elements in this compound. So carbon is 8 plus hydrogen is 2, so 2 times 4. So this will be 8 plus 8. This will give us 16. Alright, let's calculate the total valence electron V. All right, carbon is in group 4, so it has 4 valence electrons. So this will be 4 plus. Hydrogen is in group 1, so it has 1 valence electron. 1 times 4 will give us 4. So 4 plus 4 will give us 8. All right, so after doing that, so we'll say X is equals to O minus V, which is 16 minus 8, which will give us 8. So it means that in methane has a total of 8 bonding electrons. So X means 8. Now the next thing is to calculate the number of bonds. Calculate the number of bonds. How do we do that? Divide the bonding electrons by 2. So this will be 8 over 2, and this will give us 4. Divide this 8 by 2, and it will give us 4. Now the next thing is to start drawing the Lewis structure. How do we do that? For methane and for every other compound, the first thing you should consider is the elements in the compound that has a single atom, that has lesser atoms. Sometimes you also consider least electronegative elements, all right? But a shorter way of actually understanding this, the element that has one atom, for instance, now CH4, if you look at it, carbon has 1, all right? Hydrogen has 4. Hydrogen has 4, so carbon automatically becomes the least electronegative element here when you consider it in terms of being the central atom. The central atom can never be hydrogen. Hydrogen can never be a central atom. Why? Because hydrogen cannot attain octet state. A central atom should have up to 8 electrons. Up to 8 electrons in the structure. Please take note of that. So carbon will be the central atom. So after drawing the central atom, the next thing is to draw the surrounding atoms. Hydrogen is the surrounding atom, but we have 4 hydrogen, so we come here, right H, up. So in every central atom, you have up, down, left, and right. So hydrogen, hydrogen, you have hydrogen here again, and you have hydrogen. How many bonds did we calculate? We calculated 4. So what you have to do, share the 4 bonds across all. So 1, 2, 3, 4. So this is the Lewis structure of methane. Now, carbon has 8 electrons. A bond has 2 electrons. So 2, 4, 6, 8. The central atom, I told you, must have 8 electrons. The central atom must have 8 electrons. Do not forget that. All right. So this is the Lewis structure for methane. This is the Lewis structure for CH4. All right. So now let's quickly look at let's quickly draw the Lewis structure for carbon dioxide. All right. So CO2. Let's quickly draw the Lewis structure for CO2. All right. So for CO2, remember that we have to calculate the bonding electrons. X equals to O minus V. Now let's calculate the octet electrons. Carbon is also in play here. So carbon has 8. Carbon obeys the octet rule. Oxygen also obeys the octet rule. So this will be 8 times 2. So this will be 8 plus 16. 8 plus 16 will give us 24. Alright? So the valence electrons. Valence electron, remember, we use the group of the elements. Carbon has 4 valence electrons. Alright? So this is 4 plus oxygen has 6 valence electrons. So this will be 6 times 2. Okay? 6 times 2. So we have 4 plus 12. 4 plus 12 will give us 16. So it means that X will be 24 minus 16. And 24 minus 16 is 8. 8 as well. So it means that bonds here, which is the next thing, is X over 2, which will give us 8 over 2. And 8 over 2 is 4. Alright? So it means that our central atom is carbon. Carbon. So it means that we have 4 bonds. So carbon has 2 oxygens. So oxygen, oxygen. Alright? You can also draw this as this. You can draw this oxygen, oxygen. You can draw this like this. You can also draw it like this. Alright? These are called resonance structures. So let me explain resonance structures. Now, resonance structures are the canonical forms of a particular molecule or compound. There is different ways you can actually represent the Lewis structure of a compound. If you look at it, you have different positions where you can place these 2 oxygens. You have different positions where you can place these 2 oxygens. So how many bonds did we have? So let's just work with this particular structure. All right, since it's linear. So we have 4 bonds, right? So the 4 bonds, you do it like this. Always write 1 bond at a time. So do 1, 2, 3, 4. Okay, so 4 bonds. You can see 4 bonds, right? Now, if you look at it, carbon is actually happy. Carbon has attained the octet state. 2, 4, 6, 8. Carbon has 8 electrons. But this oxygen, remember, these bonds that are in between them, they are sharing it. Which means that oxygen also have 2, 4. This oxygen has 2, 4. This oxygen has 4 as well. So oxygen obeys the octet rule. Okay, oxygen obeys the octet rule. All right, so what you have to do, you now add what we call lone pair of electrons. Lone pair of electrons are in dots. They are called dot electrons. They are called what? Dot electrons. So what do we do? Lone pair of electrons. Now, if we have 4 for oxygen, it means that it needs 4 more. So you put 1, 2. These are dots. You put another 2 here as well. 2, 4. Don't put by the side, because this by the side is for these 2 bonds. They are already the left and the right, so you put up and down. Now, let's just imagine, let me explain something. Let's just imagine that carbon had just a single bond to oxygen. Now, this oxygen would be 2, 4, and 6. Let me write it here. Oxygen C. This will be 2, 4, and 6. The reason is because we have 1 bond, and this 1 bond has 2 electrons. All right? Okay? So this oxygen here has what? This oxygen has 6 what? Electrons. This oxygen has 6 electrons. Now, the reason why this oxygen has 6 electrons, dot electrons, is because of this what? This bond. So this bond here has 2. So it means that if it's a single bond, if it's 1 bond, it means that the element, the atom, needs 6 more. So you put dots. Don't do it like merry-go-round, 1, 2, 3, 4. It should not be scattered. Okay, it should be like this: dots, up, side, then down. But this one has 2 already, so it means that it's only up and down that are left. All right, so this is the Lewis structure of carbon dioxide. So now, how do you even know that you are correct? Now, the total number of electrons that you should have in your Lewis structure should be equal to what you got in V, which is 16. So go back and check what you got in V. We have 16, so let's count if it will give us 16. 2, 4, 6, 8, 10, 12, 14, 16. Okay? 2, 4, 6, 8, 10, 12, 14, 16. So that's for carbon dioxide. Alright, so that's the Lewis structure for carbon dioxide. So that is it. Now let's look at for NH3, which is ammonia. Let's quickly look at NH3, which is ammonia. So number 3, we have NH3. Alright, so how do we navigate through this? Now for NH3, now we have to calculate X, and X is O minus V, remember. So it means that we have to check for we have to calculate O, and nitrogen obeys the octet rule, so it's 8. Hydrogen does not. Hydrogen has 2 electrons, so this is 2 times 3. So 8 plus 6 will give us 14. All right. Then V, nitrogen is in group 5, so we have 5. That's 5 valence electrons. Hydrogen is in group 1, so 1 times 3. So this will be 5 plus 3, which will give us 8. So it means that X will be 14 minus 8, and 14 minus 8 will give us what? 6. So it means that bonds here would be 6 over 2, which will give us 3. Between nitrogen and hydrogen, automatically, we should know that nitrogen will be the central atom. So we put nitrogen here, surrounded by 3 hydrogens. 1, 2, 3. Remember, the resonance form, you can also draw it like this. NH, H, H. It's still correct. It can also be like this. NH, H, H. Alright? You can also say NH, okay? You can put this hydrogen here, then these 2 hydrogens here, then down. But now let's work with this first one I drew. Let's work with the first one I drew. Now, how many bonds did we calculate? 3. So you share 1, 2, 3. If you look at it, nitrogen is not happy. Remember, hydrogen can never obey the octet state. So hydrogen is usually okay like this. Hydrogen is usually okay like this. Hydrogen do not need 8. Hydrogen already have 2 electrons. This hydrogen 2, this hydrogen 2, but nitrogen does not have up to 8. Nitrogen has 2, 4, 6. Remember, a bond has 2 electrons. So it means that nitrogen needs a lone pair. Nitrogen needs a lone pair, so it's actually okay like this. So this is the structure for nitrogen. How do we know if we are correct? Remember, I told you that the total number of electrons in the Lewis structure must be equal to your V. Now, and the V gave us 8, right? So now let's check. 2, 4, 6, 8. So please, when you're drawing lone pairs, don't draw 1 dot. It must be 2 dots. A pair of shoes means 2 shoes, 2 legs of shoes. So 2 dots. Alright, so this is the Lewis structure for NH3. Now let's quickly draw the Lewis structure for SO4 2-. SO4 2-. Now if you look at this, you realize that it now has a charge. Alright, so how do we calculate the Lewis structure for charged compounds? Now it's very simple, it's not difficult as well. Okay, it's not difficult as well. Alright, so now let's look at this. So X will be equals to O minus V. Now O will be equals to sulfur obeys the octet rule, so 8. Oxygen obeys the octet rule as well, 8 times 4. So 8 times 4 will give us 32. Alright, so 8 plus 32 will give us 40. Right? So now let's calculate V. Sulfur is in group 6, so it has 6 valence electrons. Oxygen is also in group 6, so 6 times 4. Now, when you're calculating valence electrons, always consider this charge here. Always consider the charge. So 2 minus in chemistry, when a particular compound has a negative charge, it means that it has gained electrons. So when you see 2 minus here, when it is minus, put plus 2. So the fact that it's minus 2 means that you now see plus 2. If it was plus, you say minus. Minus, it has lost, but in the compound it will not write minus. So if it has lost, it will write plus for lost, but minus for gain. All right, don't forget that. So this will be 6 plus 6 times 4 is 24 plus 2. So 6 plus 24, 30 plus 2 is 32. All right, so it means that X will be 40 minus 32, which will give us 8. So it means that your bonds now will be equals to 8 over 2, which will give us 4. So it means that 4 bonds. So now where is the central atom? Central atom is sulfur. So you say S, 4 oxygen, 1, 2, 3, 4. How many bonds? 4 bonds. Say 1, 2, 3, 4. Sulfur has attained octet state. Sulfur is happy, right? As a central atom, it must have 8. 2, 4, 6, 8. But all these oxygens, they are not happy. Now look at this oxygen here. It has only 2 electrons, which means that it needs 6 more. It needs 6 more. 1 bond needs 6 more. So you write 2, 4, 6. You come here 2, 4, 6. 2, 4, 6. 2, 4, 6. So this is the Lewis structure. When you draw the Lewis structure of a charged compound, you put a barricade right like this, and you write the charge. The charge is 2 minus. Write it outside. So this is the Lewis structure of SO4 2 minus. Let's check if we are correct. Remember that our total number of electrons must be equal to what we got in V, which is 32. Let's check if we have 32. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. So that's the Lewis structure for SO4 2 minus. So now I want you to try for CO3 2 minus and NH4 plus. Alright, and NH4 plus. So basically, I've already explained to you what resonance structures are, but I'll be calculating formal charges. Now, let me explain what formal charges are. So formal charges are actually the charges of the elements in a Lewis structure, or atoms in a Lewis structure, or the charge of the overall compound or molecule. Alright, now when you calculate formal charge, the formal charge should be able to give you the exact charge of that compound. Now, the formal charge of CH4 is supposed to be 0 because it does not have a charge. Formal charge of CO2 is supposed to be 0. Formal charge of NH3 should be 0. Formal charge of SO4 2 minus should be minus 2. Formal charge of CO3 2 minus should be minus 2. Formal charge of NH4 plus should be plus 1. Should be plus 1. So the formal charge should correspond with the charge on the compound. Don't forget that. Alright. So now let's calculate the formal charge of SO4 2 minus. Please, you can only calculate formal charge until you have drawn the Lewis structure. You have to draw the Lewis structure before you calculate the formal charge. So now let's calculate the formal charge of this. Now formal charge, the formula for formal charge is valence electrons minus unshared electrons minus bonds. Alright, so valence electrons minus unshared electrons minus bonds. So this is what you do when you want. So now let's calculate for SO4 2 minus. So what you have to do is this. First of all, calculate the formal charge of each of the elements or atom in the compound, then add everything. Now let's start with the central atom, which is S. So how many valence electrons does sulfur have? Like we are using this formula. How many valence electrons does sulfur have? Sulfur has 6 valence electrons because it's in group 6. Okay, minus how many unshared electrons? Unshared electrons are called dot electrons. Does sulfur have any dot electron here? No. It's only oxygen that has dots. Sulfur does not have dots. If you look at it, sulfur only have bonds surrounding it. So 6 minus 0, then minus how many bonds does sulfur have? 1, 2, 3, 4. So 6 minus 0 minus 4 will give you 2. Now let's start for oxygen. If you look at all the oxygens here are the same. So let's say O1, O2, O3, and O4. All of them are the same because they all have the same bond and the same number of dot electrons. Now let's check for O1. Anything that happens to O1 will be for O2, O3, and O4. But this does not happen in all cases. Sometimes the representation of one oxygen can be different from others. But in this case, they are all the same. Now let's do for O1. So now oxygen has how many valence electrons? 6. How many bonds does each oxygen have? 1. How many dot electrons? 6. 6 minus 1 is 5. 5 minus 6 is minus 1. The same thing is applicable to these guys. Minus 1. 6 minus 1 minus 6 minus 1. 6 minus 1 minus 6 minus 1. So it means that the formal charge of SO4 2 minus will be equal to 2. You do like this, 2 minus 1. Don't put comma on, just solve it like this. 2 minus 1 minus 1 minus 1 minus 1. 2 minus 1 minus 1 minus 1 minus 1. 2 minus 1 is what? 1. 1 minus 1, 0. 0 minus 1 minus 1. Minus 1 minus 1 minus 2. This. Are you seeing it? So it means that the formal charge of that compound must be the same as the charge on the compound, else you are wrong. You can also be told to calculate the formal charge of only one atom in that particular compound. Alright? So I want you to go calculate the formal charge of CO3 2 minus and NH4 plus. Alright? So calculate the formal charge of CO3 2 minus and NH4 plus. But you must first of all draw their Lewis structures before you'll be able to do that. Like I said, if you're not subscribed to this channel, do well to hit the subscribe button, and also like this video, share this video. If you have any question whatsoever, ask your question in the comment box. If you want to reach me, all right, you can reach me on WhatsApp via 08140906243, and my name is Mr. Nisike, the CEO of Nisike Academia. All right, so you can text me on WhatsApp, and of course I'll reply to your message. All right, so share this video. Thank you, and see you in the next video.